Good morning. Good morning. I say good morning. It's probably you working at nighttime, me working in the morning, because I'm working in the morning, you're working at nighttime. I don't even know. What's going on? What's going on? Ready? Ready? I'm going to say everything twice. I don't know why. Why? I just woke up. Lights are killing me. Eyes are killing me. You're probably thinking, wow, that's professional. Why don't you come do a video while you can't even see? All right, kids. Since it's such a professional job, I expect you to hit subscribe. Donate. You know, the ads make sense, hit them. If the ads don't make sense, just get rid of them. It doesn't matter. Let's get going. Looks like we got some stuff to do today. This is a warm-up. So the warm-up's not bad. We'll just factoring warm-up. Difference of perfect squares. You should know how to do. Ooh, my pen's working. Oh my god, this is crazy. X plus 2, x minus 2. You know this stuff. Over here again, difference of perfect squares. What do you mean? What are you talking about? I don't understand. It's 49. Isn't 49 7 times 7 and 9, 3 times 3, 1's plus, 1's minus? Oh yeah. Okay, well it's just 49 is 7x and 7x. 3y and 3y. It's not a big deal. Don't sweat it out. It's not a big deal. So that should make this one a little bit easier now that I just got rid of the numbers and all I did was left the letters. Letters, numbers, x and x, y and y, plus and minus. When there's two things like this, binomial, you should be looking for either the difference of perfect squares, which all three of these are, or you should be looking for a GCF. Oh, we get the FOIL or factor or double distribute, not factor. FOIL or double distribute, whatever you want to call it. I don't care. X times x is x squared. And then, you know, I've been trying to get you guys to do this stuff in your head. Plus 3x and minus 4x is minus x. And then minus 12. Ka-ching. And if you factored that, it would be this. Oh, God, that felt good. Sorry. That was right in the microphone, too. You probably heard that one. Better on that end. Better on that end, though. Oh, my God. I got to factor this one. This one's easy. X squared plus 9x, 2x, 11x plus 18. X squared minus 18x plus 80. Expresses a trinomial. What does that mean, Mr. Krause? It means double distribute, you friggin' whack job. I'm going to write it twice. Now, the cool thing about these is you get x squared, and then it's minus 5x minus 5x. You're just doubling that, so it's minus 10x plus 25. And again here, there's another x plus 3 here. So it's x squared plus 3x, which is plus 6x plus 9. Notice that half of this squared is this. Half of this squared is this. Cool stuff. So, I think I talked about that. Difference of perfect squares, right? Beginnings are the same. Ends are the same. One's plus, one's minus. Multiplying binomials, right? This is just x squared plus xb plus xa. Plus AB. Oh, I don't know why I put this one in. This one is just, everything's kind of different. But this one here, this is the one I was just talking about. This is the one where it's, if you wrote this twice, I'll do it on this one. You get A plus B. You get A squared. And at the end you get B squared. Well, this is just two, this is AB and this is AB. So it's just double whatever that product is. So plus 2AB. And this one, the only difference between this one and this one is that this middle sign is now a minus. So it's still A squared. It's still positive B squared because it's negative B times negative B. And then the outsides and insides are minus AB and minus AB. So that's minus 2AB. Not a big deal, kids. I want you to take a look at these. We are going to triple distribute here. So we're going to get x times this, which is x cubed. and x times this, which is plus 2x squared, and x times this, which is plus 4x. And believe it or not, all of this is eventually going to equal this stuff over here. So if you're thinking about it, all this stuff in the middle is going to go away, and we're just going to keep whatever I put back here at the end, right? Doesn't that make sense? So minus 2 times x squared is minus 2x squared. You'll notice that's gone with that already. Minus 2 times positive 2x is minus 4x. Notice that's gone now with that. And then minus 2 times 8, or 4, is negative 8. So I end up with x cubed minus 8. All of this is the sum of perfect cubes, is going to turn out to be this. Let's triple distribute. Notice I'm going to keep this, x cubed. But then everything else is going to go. All this stuff in the middle is going to cancel. And I'm only going to keep this thing out here, which should be a plus 1, I'm hoping. And doesn't that make sense? Plus 1 times plus 1. It does. So, let's check. X times minus x is minus x squared. X squared times 1 is plus 1x. 1 times x squared is plus 1x squared. Cancel. 1 times negative x is minus x. Cancel. Cancel. And then 1 times 1 is 1, so I end up with x cubed plus 1. Now, why am I showing you that? Well, first of all, I want to prove to you that, yes, in fact, that you can factor the difference of perfect cubes. But you can also factor the sum of perfect cubes. You cannot do that with square roots. You can only do that with cubes and difference of perfect cubes. Sorry, something on my glasses drive me crazy. And then we're going to take a look at, I don't know where my mouse is. We're going to take a look at this pattern of signs. This is a minus, this is a plus, this is a plus. This is a plus, this is a minus, this is a plus. Do you see any pattern yet? I'm going to teach you the pattern. We're going to do it. Oh, I got one more to go. I don't know why I got one more to go. So this is x cubed. And this is minus 27. And then all the rest of the stuff just goes away. 3x squared minus 3x squared. Plus 9x minus 9x. And it just turns out to be that. So here's another difference of perfect cubes. Did you see anything? Did you notice anything about the signs? Minus, minus, plus, plus. So what's the pattern? What is the pattern? We're looking now at perfect cubes. So this one, let's see if you can come up with the pattern. I'm just going to tell you what it is, and let's see if you can come up with the pattern. With the signs, all I'm asking about, what's the pattern of the signs for now? Then I'll teach you the pattern for the other stuff. So first of all, I want you to understand it's going to be a binomial times a trinomial. This is going to be, and this is x cubed and b cubed. It only works either the sum of perfect cubes or the difference of perfect cubes. So this one is going to be x plus b, x squared plus, excuse me, just screwed that up, minus xb plus b squared. This one is going to be x minus b, x squared minus plus xb plus b squared. Anybody see it? Here's the pattern. It's copy, change, always positive. I should have made that bigger. Copy, change, always positive. Let me tell you what I mean by that. First thing you're going to do, I'm on the wrong place. First thing you're going to do, copy the sign. Whatever it is, change it. Last one's always positive. Copy the sign. Change it. The last one's always positive. Let's go back up and see if that makes sense up here. Copy the sign. Change it. The last one's always positive. Copy the sign. There it is. Change it. Last one's always positive. And yes, it does it for the last one. So that's what we're going to be doing. Now, let's talk about the middle. The beginnings and ends aren't bad. The beginnings and ends are not bad. It is whatever the thing is that's being cubed squared. And we're going to talk about that. That gets a little crazy. In the middle, it's the product of the two things. So this is the first thing squared. This is the second thing squared. And the middle is the product of the two. Now, we don't worry about the sign. We just worry about the product of the two. So let's see how that's going to work. First thing we got to do is recognize that we have the difference of perfect cubes. And in this case, it's true. I have x cubed plus 5 cubed. Because you got to figure out what that thing is cubed. All right, once you have that determined, then we can do our signs. It's a binomial times a trinomial. I'm going to put our signs in. I always put the signs in first. Then I don't have to worry about them. Copy, change, always positive. I couldn't do that before because I was trying to teach you the pattern. Copy, change, always positive. Now in this first one and the second one, it just goes whatever these two things are. So in this case, we're going to put in x and a 5. Here and here go whatever those things are squared. X squared, 25. Don't put 5 squared there, put 25. In the middle goes the product of the two. 5 times x. And always put the number first. All right. When I factor perfect square trinomials, the difference of perfect cubes and the sum of perfect cubes, I like to drink my leftover brewer's coffee from yesterday. Reheated, little extra cream, little extra sugar. It just makes me a little sweeter. Yeah, have your parents in the room when that one goes off and tell me they don't tell you to turn it off and stop watching that whack job. Okay, kids, let's go. Let's move. By the way, if you're watching my videos and you're loving them, hit the like button, hit the subscribe button. If you got a comment like, man, Mr. Krause, your hair is so long, I think you can ponytail it. Or, Mr. Krause, your hair looks so good long. You should keep it long because you don't look bald at the top of your head. Not at all. Also growing a beard for No Shave December. Nah, just kidding. I was just being lazy this week. So, okay, you ready? Let's get back to work. This is a cube. This is 4 cubes. So now that I've recognized it as the difference of perfect cubes, there's something on my glasses. It's driving me bonkers. I think it's scratched. Son of a... Oh, wait, no. I think I got it off. I just got a big fat finger mark on there. Now that I've recognized it as the difference of perfect cubes, now what I'm going to do is set it up. It's a binomial times a trinomial. I'm going to put my signs in first. Of course, I don't know where my mouse pointer is, so... Oh, there we go. Computer's starting to act up. Yay! It's so much more fun when it acts up. I'm going to put my signs in. Copy, change, always positive. In the first one goes the A. In the second one goes the 4. This will be them squared. Squared. A squared. 16. That's 4 squared. In the middle goes the product of the two. 4A. Now we're going to get a little more complicated. Now we're going to make things a little tougher for you. So first thing I got to do is figure out if that thing is a perfect cube. Well, 8's a perfect cube. It's 2 times 2 times 2. And x is a perfect cube. That's x times x times x. So I think this is 2x cubed. And that's the thing you got to start thinking about. That's the hard part about this job, about this stuff. And then over here, you've got 3 cubed. So now I've got the difference of perfect cubes. I can say, okay, binomial, trinomial. Let's toss the signs in. Copy, change. No, pen's acting up. Always positive. So in here goes just the 2x, nothing else, and the 3. No squareds, no cubes, no nothing. But be careful about this one. In here is going to go this thing squared. So I have to put in 2x squared in there. Well, 2x squared is really 4x squared because this is 2x times 2x, which is 4x squared. Down here goes 9. That's the 3 squared. And in the middle, I just do the product of these two. And if you think about it back here, what's the product of these two things? Oh, the product is 6x. All right. This is 3b cubed minus 5 cubed. Oh, my God. Oh, that hurt my back. Oh. Lovely weekend. Threw my back out. That's what happens when you get old. You're not old, Mr. Krause. Your hair looks so good today. What? Shut up, creep. All right. Copy. Change. Always positive. So, in here just goes these two things. 3b and 5. So, 3b and 5. At the beginning here goes squared. 3b squared. That's 3b times 3b. 3 times 3 is 9. b times b is b squared. Over here goes the 5 squared, which is 25. And in the middle goes the product of these two things. Think about the product of these two things. Don't worry about the sign. The sign's already there. It's just 15b. There it is, kids. Oh, I did tell you. It's a right triangle. I didn't need to do that. I could have just done this. So, Pythagorean Theorem, the 2 legs squared equals the hypotenuse squared. Is that true? Weird. Let's see. X squared minus 1 times squared. What am I doing? All right, so let's do this the right way. So we're going to use the Pythagorean Theorem. A squared plus B squared equals C squared. Well, what is A squared? A squared is X squared minus 1 squared. Plus 2x squared equals x squared minus plus 1 squared. My God, my eyes. So, now I can't even blame the brightness. Let's see. Everything needs to be written twice. Now, some of you should have been able to do this in your head. So this is x to the 4th. Now, remember, when we have things that are exactly the same, we're going to double the product. So I didn't need to really write this twice. I knew this was going to be negative x squared, and I double that, so it's negative 2x squared, and then plus 1. This just doubled is plus 4x squared. And then this thing doubled, it's x, this thing squared, x to the 4th. This thing squared, plus 1. And then the product of these doubled. X squared, so it's plus 2x squared. Ow, 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 ow. Oh, I forgot the plus 1 down here. All right, so these two make 2x squared. So I get x to the 4th plus 2x squared plus 1. Does that equal this? X to the 4th plus 2x squared plus 1. Yes, it does. Yes, it does. A little fun with geometry in the middle of a whole bunch of factoring stuff. Show that the two forms of the quadratic are equivalent. So do you remember when we changed things from standard form to vertex form? So I want to show these, and this is just practicing double distributing perfect squares like this. So again, we're going to square this. We're going to square this. So x squared and plus 1. But because we got to really write it twice, and you don't want to do things stupid and just say, oh, it's just x squared plus 1. It's not. You're going to multiply these two things and double it. So x and then double it. So it's plus 2x minus 6. And then this is just x squared plus 2x minus 5, which is the same as here. Again, we're going to double distribute this. X squared plus 1. In here is this is doubling is x, so we're going to double it, get 2x. And that's what this thing is, and then minus 9. And then obviously that's just this. So are you getting good at double distributing that in your head? Can you do it? I hope you can. That thing with vertex form and directrix and focus form, do you remember that? Some of the kids were able to do it a lot quicker because they were doing the double distributing stuff in their head. So if I want to prove that these two things are equivalent, I got a lot of double distributing here to do, but I'm going to do it right in my head. So this is x squared. This is plus 4. And in here goes the product of these two is minus 2x. Double it, minus 4x. Plus y squared, 9. So y squared and 9. Multiply these two things, I get 3y, but double it, so it's 6y equals 9. The 9's cancel. So I end up with x squared plus y squared minus 4x plus 6y. I'm not coming up with these being the same. I don't know why. I wrote them as the same. I could have sworn I put them as the same in there. I just finished the answer key for your homework, so I know that's right. I thought I did these notes perfectly. Let's do the completing the square in this. So this would be x squared plus or minus 4x plus 16 plus y squared plus 6y plus 36 equals negative 4 plus 16 plus 36. So this is x minus, oh, this should be 8. Oh, all right. We're going to do it backwards. I just ran out of room and then I started screwing up. So it's x squared minus 4x plus square plus y squared minus plus 6y plus square equals negative 4 plus square plus square. So in this goes half squared. That should be 4. And then we put our parentheses down here, which is x minus 2 squared. So that matches. And then this half of this is plus 3 squared. And in here goes 9. So over here we should have a 4 and a 9. So that equals 9. Boom, done. So what was I doing before? Now I just showed that this is equal to this. But now I should be able to take this thing, double distribute out, maybe not screw it up, and then do it right. So I'm going to do this first. Remember, it's x squared and plus 4. Maybe I put minus 4. Did I put minus 4 there? And then if I multiply these, I get minus 2x, but you have to double it. Oh, that's what I didn't do, minus 8x. That's it. Wait, what am I doing? Oh my God, Krause, wake up. These are minus 2x. I double it, I get minus 4x. Oh my goodness. Oh, there's the plus 4 I missed earlier. Son of a so-and-so and such and such. I bet you if I can undo all this, I would figure this out. Now I'm going to double distribute this. It just gives me a double practice of double distributing. So it's plus y squared plus 9. And then in here goes 3y, but we're going to double it, so we get plus 6y equals 9. Well, the 9s cancel. So this 4, I just forgot to put down here. So it's really x squared plus y squared minus 4x plus 6y plus 4 equals 0. And that is, lo and behold, the same as here. I knew it worked. Oh, see, even math teachers make mistakes once in a while. We're going to do this one a little bit better. Hopefully it works. Going to double distribute this. X squared, 1. Multiply them and double it. So plus 2x. Plus, square it and square it. Y squared, positive 16. Multiply them and double it. Minus 4y minus 8y equals 16. Well, the 16s cancel, and I end up with x squared plus y squared plus 2x minus 8y, and then plus that lone little 1, which I forgot earlier, equals 0. And let's see, does that equal this? Sure does. How are you getting at double distributing these things? Are you getting better at it? Hope so. Hope so. Almost done, kids. Last one. Last practice. Now you should be pausing this and trying these on your own. Double distribute this. X squared. Multiply them, you get minus x, so it's minus 2x plus 1 plus y squared. Multiply them and double it. Plus 2y, plus 4y plus 4 minus 4. Oh, these cancel. And let's see. This is a 4y. Is this all the stuff that I have over here? I have an x squared, I have a y squared, I have a minus 2x, I have a plus 4, and I have a plus 1 at the end. Lo and behold, it works. How good are you getting at double distributing these things? A couple things. The big thing I want you to take away is when you are factoring trinomial, or you're factoring the difference of perfect cubes, it's a binomial times a trinomial. Copy, change, always positive. I don't care if it's this or if it's this. It's copy, change, always positive. So in this case, you put x and y, x squared and y squared. I don't care what the signs are. X and y, x squared and y squared. And in the middle goes the product of the two, xy. xy. You'll see that's the same math everywhere. You just take care of the signs first, and they'll take care of you. Much like Brugger's coffee takes care of me in the morning, which I finally woke up. It's only 5:41. I've only been up for an hour, and I finally woke up. All right, kids. It's been great. It's been fun, but it hasn't been a lot of fun. It's been a lot of fun. Just kidding. Bye.